Hi there. Now, before I will virtually take you flying on Mars with a Google Earth Flight Simulator, I would like to make a few general remarks on this planet in the hopes that you will be better able to put into a context what you will see and hear later. To begin with, Mars is a considerably smaller planet than Earth. Its diameter is 53% of that of Earth, and what we are having in front of us here is an elevation map of Mars. Now, what does elevation mean on Mars? On Earth, we have a sea level, which we take as zero reference, and everything above is plus and everything below is minus. Such a sea level does not exist anymore on Mars. So what was chosen as a zero reference was the average height of the surface, or its average distance from the center of the planet. And the zero line, as you can see here, is about here on this vertical scale. If it's so low, it means that there is just very little, very high territory on Mars. So when we look at Mars, we see immediately that it's a very asymmetric planet. The entire southern hemisphere is covered by mountain ranges and craters, and it has two major impact areas, one called Hellas, the deepest place on Mars, and the other is Argyre. And in contrast, the northern hemisphere of Mars is comparatively smooth and low, much lower than the southern hemisphere on Mars. And as it turns out, between 4 and 3.5 billion years ago, almost the entire northern hemisphere of Mars was covered by a giant ocean. The surface level of that ocean being at about minus 2,800, into the green at the margin between blue and green, as you can see here. And as I said, and with a depth of about a good 3,000 meters. And 3.5 billion years ago, Mars was still very warm from its formation. So we had all this water-laden air rising the southern hemisphere and raining off in torrential rainfalls, forming great outflow channels here and here. This is actually an extension rift from the magmatic pressure below the crust of Mars, but it also became an outflow channel. And well, where there was water, there could have been life. I will make a long story short. The most accepted theory today, as far as the origin of life is concerned, is that around hydrothermal vents, which on Earth occur primarily along mid-ocean ridges, which on Mars do not exist. But on Earth as well on Mars, they do also exist, and especially on Mars, it seems like on higher areas, and we can identify possible hydrothermal vents on Mars spectroscopically from orbit. And I would like to take you to one of these places where Earth meets water, where there was shallow, warm water possibly in the past, and these are the areas where normally you seek for signs of water, or if possible life, if you can land there, which would not be possible in this one because it is too accidented. Of course, the too uneven. Of course, the most interesting places of Mars are the most uneven ones and therefore the most difficult ones to land. So, but with a virtual airplane, we can do something like that. And we will, in order to do that, we will first go to visible imagery. Click away the side panel. And this is the area where I would like you to take you flying. It has formerly been a frozen lake, it is said, and it had an outflow channel into the major outflow channel Ares Vallis, which leads northwards to the great ocean. So I will put our airplane down here, then fly through this valley, in between these mountains, and then across all of this rather strange territory, through this gap in between these two low plateaus, and then across this high-resolution strip. We will leave that high-resolution strip lying on the left, but we will fly across this one to have a closer look at these bright sediments, and then fly back into the second valley around the point here, and then to the end of this high-resolution strip, which we will fly down. Here we will change airplanes and just go real fast up here and fly through a couple of these strange valleys among these table mountains and fly through this area, then back to the entrance channel, fly through the entrance or the outflow channel, fly through the outflow channel, and then look for a place to land here about. Okay, and this here is a great artifact, mishap in data transmission. There are data from the east to west, but not from north to south. So this cannot be remedied anymore. Now, if this were the Earth section of Google Earth, there would be a little person appearing here, a little symbol which you could drag onto the surface here, and it would end up in pedestrian view. Unfortunately, this option does not exist in the Mars section of Google Earth for reasons unknown to me. So I will have to stick our noses into the dirt until the program finally lets us get into the pedestrian mode, which is now. Okay, so we're on the surface of Mars now. What we are seeing is orbital photography superimposed on a laser altimeter altitude map. And but we're still on foot, so let's get into a suitable airplane. This we do by clicking on Tools. Herramientas is Spanish for tools, and then we enter the flight simulator. Now the flight simulator gives us two options of planes to choose from, one of them being the General Dynamics F-16, which you can see better here actually. One fantastic airplane can fly at twice the speed of sound and rise vertically until you can see the stars. At least in this simulator it can. And it flies like on rails. Some pilots say that you don't fly it, but you wear it. Well, it's a fantastic airplane, but there's one thing it cannot do, and that is fly slow and low. In fact, the nicest thing for this you would be to have a helicopter. So we will choose a different airplane, which is just good just for that, which is the Cirrus SR-22, a four-seater, and the one and only airplane in the world which has a built-in parachute. So if you get in trouble in the air, you pull a handle on the ceiling of the cabin and out comes the parachute, and the airplane will end up damaged, but you will come out fine, and your passengers. And above all, it can fly slow and low, so we can see geological detail and not just geographical detail. And geological detail is what we will be after on the first part of our flight. So we will choose this little plane here. And here we are on the surface of Mars. It seems like we changed our orientation a bit, but I'll just assume everything's okay. A few words about the flight instrumentation. This here is the throttle. So we can see down here there's zero throttle, this is full throttle. These three scales are not unimportant for us. This vertical scale on the left indicates the airspeed, the speed relative to the surrounding air in knots. 1 knot being equal to 1.85 kilometers per hour. This you can imagine is the compass. This here is the relative depth or height above or below the zero reference line on Mars, as I explained, the average distance of the planetary surface from planetary center, also given in feet. So we're at minus 11,400 feet below the zero reference on Mars, but fortunately we do not have to calculate this because the metric value is given to us down here on the bottom right corner on the screen. So at minus 3,474 meters, which would mean about 500 meters under the surface level of the former Martian ocean. So now I think it really is time that we get into the air. I will hold on to this, and here we go. Maybe a little bit of flaps. Okay, we are airborne. Let me just take out the flaps. We're at full throttle. Now, these two mountains here in front of us are marks worn out by water flowing into the channel behind us. And the channel behind us I would like to show to you a little bit more of detail, because this is it. And you can see loads 1, 2, 3, 4, 5, 6, 7 sedimentary layers here, which became exposed through by the water flowing into this outflow channel, through which we will later on end up flying ourselves. So these are all sedimentary layers. And just like this, also these two bright layer sandwiching this dark layer are sedimentary layers. These are called scour marks. So scour marks, they're considered as scour marks made from the outflow of the water. We are flying in the direction of the flow of water. We are flying against the direction of the outflowing water. So let's you can see all very round shapes, which presumably have been produced by the water flowing along here. So here you have more scour marks in the direction around the corner, going around the corner here in the direction of the former water flow. And then down here on the left of the scour marks you have parallel ripples. And parallel ripples are a giveaway for the presence of sand, in this case bright sand. Let's turn back and the brown color of this slope is shadow. It's just how shadow comes out in this color photography. Dark material is either sand, dark sand, as you can see come here right now, or in most cases it's shadows thrown. Parallel rivers, meaning sand below us. I do of course wish the surface resolution on the ground here would be as good as it is in the Earth section of Google Earth. It should not cost too much money to fly a better camera around Mars. The highest mountain on the left is about 580 meters high, to give you an idea of height here. So we are flying about 100 meters above ground. It dries up a little bit. These curved lines you see here in front of you on the ground are shadows made by stone ledges. And this green color on the mountains in front of us has nothing to do with chlorophyll. It's not lichens, it's not moss, but it's an artifact um, caused by this barcode, this artifact barcode you saw next to the outflow channel when we looked at from above. So we are not about to discover life on Mars here. And there you have another stone ledge throwing a shadow, making these curved lines on the ground. Yes, and now take note of all these white precipitations on the ground, all these white outcrops. At any rate, right now we're getting into a very different landscape from from where we have been before. It's kind of a very flat valley with low table mountains. One of them being right where I'm moving the cross now. One moment. The white cross is now right over a table mountain right here. Okay, but there are more in the background. So how did all this come about? Why did Mars become so dry? Where did all the water go? Well, for one thing, about 18 or something percent of its water do still exist below its surface in the form of ice, but the rest has been taken away due to a circumstance which we do not have on Earth, which is that Mars lacks a global magnetic field. On Earth, the global magnetic field can shield the atmosphere from the solar wind, which is a stream of charged particles coming from the sun, which on Earth gets caught up in the Van Allen belt. Mars doesn't have this. So when the atmosphere was taken away and Mars cooled down, it couldn't take all this water anymore, and the water on Mars froze. What was left of it, and then the atmosphere nonetheless became less and less and less. Today we have 0.6% of the atmospheric pressure of Earth on Mars. So you couldn't pour water into a glass on Mars because it would boil away immediately. But when the pressure becomes sufficiently low, ice starts to evaporate as well. It's called sublimation. So you had these the surface of former lakes together with frozen lakes, meaning dry lake and frozen lake, on this being deposited sediment, and where the was a frozen lake, the ice under the sediment evaporated away, and the ceiling of the cavity collapsed, and this is how all these rock slabs come to lie on the surface here. We have seen a couple of them, but I was so busy speaking that I couldn't point them out to you. So let me get me back on course. It is difficult to speak about such a complicated issue and fly an airplane at the same time, even though it's only virtual. Here we get to see some of these rock slabs lying on the ground with sand in between. There's another one right below the -5 degree pitch line. The horizontal line between the zeros, that's the artificial horizon. It should always stay on the horizon, stay parallel to it. So you know how your airplane is directed if you can't see. Actually, it was astronomy which got me into virtual flying, but that's how life goes. And I've never flown anything but the Google Earth flight simulator, because I am not interested in flight simulators that show me the interior of the cockpit. Now, something we could do here, which I will try to do here, is measure the depth of this sediment if it allows me to do so. "220 meters, well, this could be perspective. This would be perspective. This is not 220 meters high. Okay, sorry about this. Now this gray area coming up on the left is that first high resolution strip, which I will not show you. I wanted instead to just show you how this cap material on top, which I just unsuccessfully tried to measure, what aspect it has on normal, well, in black and white, what is normal on these photos. Okay, and what we see coming up on the right is the high resolution strip we will in fact fly across. I just wanted to show you this ledge here in front, which is filling the gap in between these two low plateaus. We are flying over one, and over there is the second one, and one could imagine that at some point in time there was water running down this ledge, but it also might just be a frozen and collapsed pond. Yeah, to give you another impression here, from here to here, that is about 4.3 kilometers. Here you have a few more of these rock slabs, and this ledge from the bottom to the top is about 650 meters high. take you into this ditch, this corner, so we can compare the ripples in the color photography and in the black and white photography, and the gain in definition, which we do of course have in black and white, where we can actually see little stones in between the black ripples. Now this you can of course not do in a fighter plane. This is kind of like rock and sand. But primarily sand, it seems to me. Where there are ripples, there are no doubts, of course. There's a little bit of rock slab here. The dark lines on the brownish, the ochre surface on the left are shadows. This is unquestionably rock. There are so many white outcrops, white sediments. It's no wonder there's so much precipitation where so much water evaporated, and that there is precipitation on the ground here. You can see on a different place. Well, let me just make one more round here because it's really interesting. You see below you these fine dark ripples, and if we're lucky, well, here they are. Here you can see nicely the dark sand where there has been impacts, and the wind has been blowing the dark material at the bottom out, so you can see the predominant wind direction. Now these high resolution strips, they're always made from two strips, as it seems. and where these two strips overlap, black becomes blue and white becomes yellow. And this is what we just saw. Okay, one last turn. And okay. There are clearly defined borders to this white outcrop area, even though it's further down it seems to have leaked. There have been lots of phyllosilicates and hematite identified in Aram Chaos, so so the former presence of liquid water is pretty clear. So now we're on this cap material again, where we were before we flew across the gap between these two low-high plateaus. And here now you have it in black and white. You can see dark dunes, sometimes at least, and it's in the shallows, in the ditches. So we are trying to fly as low as and slow as we can. It's probably possible to land here. I've never tried it. Much better than where I will try to land later. Um, okay. Well, we're back into the second valley, as I called it, and I will just toggle away the head-up display so we can enjoy the landscape without any, without any interference. Sorry about that. Yeah, if in 1972, 75, when I was 20 years old, somebody would have told me that I will not live to see a man fly to Mars, I would have laughed about that person. Today I have no doubt that I will not come to live it. It seems so close, but it's still so far. And if NASA says that they will do it in the 30s, it's simply because they know they will never be able to do it before. And as far as Elon Musk is concerned, I do not doubt that he's a brilliant engineer, but it looks to me like his enthusiasm is just taking him away. There are too many key problems he'd rather not think or talk about, like radiation, for example. So the only hope I really have is that in 20 years, or at least or 10 perhaps, this year will look like it looks in Google Earth, like in the Google Earth section of Google Earth. There will be better, that there will at least be better surface photography. And not only, I'm not talking about virtual pilots, but about scientists, which would rejoice if they had everything here in such great detail as we have it in Google Earth, in the Earth section of Google Earth. Yeah, that dark spot there seems to be, I'm not sure whether it has surface structure, so it seems like it's a shadow and not a cave. So we are on our way to the second high resolution area. All of these dark stripes on the right are shadows. Here comes the second high resolution strip. There's more dark sand ahead than there was behind us. can see ripples in the dark sand here. Dark sand is being more coarse than the white sand. Bright ripples to the left and dark sand in front of us, always accumulating in the deepest points of the depressions. I can just barely see the ripples in the black sand here. Yeah, this here is something I don't know what to think about. It looks like the sun is coming from the right, and that the dark part is shadow, but it's completely filling this crater, and even has a couple of little rocks on top. So if it's a crater, it's certainly an unusual crater. And again, we're back on over this cat material. Okay. This is about the moment when you change planes. And this time we take the fast one, the F-16. We want to cover a lot of ground. And this is not more geographical than geological, what we'll see now. You can see our speed rising. You can see the crater rim coming up in the background. At 1,300 knots, we will have reached Mach 2, twice the speed of sound. Okay, let's kill some speed here. Well, now you come into this landscape of table mountains standing side by side, and the question here, of course, is again, how did this come to be? The Martian ground had apparently a very great capacity of storing water underground, and what we have here then might have been catastrophic groundwater releases, meaning the water broke out of the ground and took it with it, and what was left were these table mountains. Another theory talks about Marsquakes. I suspected as much as a combination of both, meaning Marsquakes and catastrophic groundwater loss. I don't think there's any place on Earth where table mountains, large table mountains, stand side by side this densely as it is the case here. But it is a landscape very typical for Mars. There are other places where you have these bigger places like this, where you have groundwater, where you have these table mountains standing side by side. And in between you always have the ripples of sand, of course. And what is coming up in the back is the crater rim, which is again a few meters higher than these table mountains, as you can see. Now I will try to find my bearing back towards where we started out. Not like this. Okay. Let's speed it up a little. Okay, now we're getting back to where we came from. Here is this sediment slope I showed to you at the beginning of the flight. We're getting into that channel again. I mean, this must be rocky ground, otherwise it would not be so rich in structure. These are not dunes, what we have below us. And here is the bottleneck through which everything had to flow, which wanted to get out of Aram Chaos. And we're coming through a strip of exceptionally bad ground resolution. I don't know from when this image comes, but it'll be right over. Some nice sedimentation on the rock slope on the left. Little shadows, I suppose. Wish I could see this in higher definition. Okay, now it's time to look for a place to land which in 2 or 3 cases tend to work with me. This is not easy to land a jet fighter which touches down at 350 knots and find a place that is smooth enough for it to land. Okay, looks like it's working out. Okay, here we are. Just have a look back to where we came from. It's from here. Well, from here, you just roll down this hill. Good. I hope you enjoyed the flight, and there will be more because there's plenty of to see on Mars. And meanwhile, I wish you a good day. Ciao.